Demonstration problem. Pietro has a mass of 70 kilograms and is standing at the center of a tightrope that's attached at the same height of two poles, as shown here, with each rope having an angle of depression of 30 degrees below the horizontal. What is the tension in each side of the rope that he is standing on? Let's examine the forces on Pietro. First of all, look at the contact forces. He's standing on the rope, so the rope touches him. T sub R represents the tension in the rope on Pietro's foot to the right, and T sub L represents the tension by the rope on the foot to the left. The field force is the gravitational force, or the weight, which is applied at Pietro's center of gravity. It acts downwards. We are only considering concurrent forces. We are not considering any possibility of rotation. Therefore, we are interested in where the lines of actions of all the forces on Pietro intersect. That is this point here, where the tension in the right part of the rope is concurrent with the tension in the left part of the rope and the weight vector. This will be the origin of our coordinate system for our force diagram. Note that by symmetry, T sub R, the tension in the right side of the rope, is T sub L, or the tension in the left side of the rope. Therefore, we can call both of these just the tension T. We take this point of concurrency and make that the origin of our force diagram. We then put the tails of all the vectors at the origin. Here's the tension in the right part of the rope. Here's the tension in the left side of the rope. Here is the weight vector. We know that by alternate interior angles of parallel lines, that when we construct a line parallel to the horizontal line drawn here, that this angle is 30 degrees, so this angle is 30 degrees, like this angle is 30 degrees. Therefore, when we draw the right triangles that are formed by the x and y components of the tension on both sides, we see that the angle between the tension vector and the x-axis is 30 degrees on both sides. What we have in our force diagram is a tension vector, and the right triangle has a hypotenuse whose magnitude is the magnitude of the tension vector. The unknown is to find the magnitude of the tension vector, and so this boils down to finding the hypotenuse of a right triangle. The tension on both sides has a magnitude of T, which is unknown, we need to find that, at an angle of 30 degrees above the horizontal on the right and on the left. The unknown. What is the magnitude of the tension on the right and on the left in the ropes that Pietro is standing on? The equation. Since Pietro is at rest, he's in equilibrium. This means that the net force along the x-axis is 0 and the net force along the y-axis is 0. The net force along the x-axis is minus the x component of the tension on the left plus the x component of the tension on the right, that's positive, plus the x component of the weight vector. But the x component of the weight vector is 0. The net force along the y-axis is positive the y component of the tension in the left vector plus the y component of the tension in the right rope minus the y component of the weight vector. Since the weight vector is directed along the negative y-axis, its y component is minus the magnitude of the weight. Substitute. For f net of x, we get f net of x is minus the magnitude of the tension in the left rope times a cosine of 30 degrees plus the magnitude of the tension in the right rope times a cosine of 30 degrees is equal to 0. These two subtract, giving us 0 is equal to 0. We know 0 is equal to 0. There's no useful information here. Therefore, we must move on to f net of y. Substituting in for f net of y, we get f net of y is, for the y component of the tension in the left rope, we get the magnitude of that tension times the sine of 30, and that is positive. Plus, for the y component of the tension in the right rope, we get magnitude of the tension in the right rope, which is the same as in the left rope, so we just call it magnitude T, times the sine of 30 degrees, that is also positive. Then we need minus the y component of the weight vector, which is minus the magnitude of the weight vector. We know that weight is mass times the acceleration of gravity. In the givens, we have that the mass of Pietro is 70 kilograms. So we have minus mass 70 kilograms times 9.80 meters per second. All this is equal to 0. We have written one equation in one unknown, where the one unknown is the magnitude of the tension in each rope, which is what we are trying to find. Now we proceed to solve. These are two like terms, so we simply get twice the magnitude of the tension in the rope times the sine of 30. We move this to the other side, and we get that is 686 newtons. Solving for t, we get that the magnitude of the tension in the rope, each rope that is 686 newtons divided by twice the sine of 30 degrees. That is 686 newtons divided by twice times 0.5, because the sine of 30 degrees is a half. That gives us that the tension in each rope is 686 newtons. And so we have solved the problem.